So today discuss about Wolfe's method to solve the quadratic programming problem. So objective function is minimum. So here is a type of a problem, and this is the minimization of the objective function types. Is 2x1 square plus 2x2 square minus 6x1 minus 2x1 x2, and subject to constraint here is minus x1 minus x2 is less greater than minus 2, and x1 is greater than 0 and x2 also greater than 0. So first we need to rearrange this constraint in less than equal to sign all. So we then negative sign multiply both sides, and we get this, and then we get this. Then we add a slack variable to equate the right hand side is equal to 0. x1 plus x2 plus s1 minus 2 equal to 0, and minus x1 plus s2 equal to 0, and minus x2 plus s3 equal to 0. Then we use Lagrange function. Then Lagrange function is objective function, and plus lambda 1 into x1 plus x2 this constant, and lambda 2 into this constant, and lambda 3 into this constant. Then we derivative with respect to x1. Then 4x1 minus 6 minus 2x2 plus lambda 1 minus lambda 2 equal to 0. And L with respect to x2, then 4x2 partial derivative, 4x2 minus 2x1 plus lambda 1 minus lambda 3. Okay, and del L del lambda 1, del L del lambda 1 is equal to x1 plus x2 plus s1 minus 2 equal to 0. Okay, then we need this 2 equation and this 3 equation, so write it and make sure right hand side also is equal to 0 or a number, right hand side constant number. Then we add artificial variable a1 and a2 in equation number 1 and 2, and but we don't need, but here is s1 also add before, so we don't need. So a1 plus a2, then w minimum, the objective function is equal to a1 plus a2. This is actually method of two phase method, simplex method का एक then minus w max is equal to minus a1 minus a2 minus 0 s1. This is the objective function. So we get minus w is plus a1 plus a2 equal to 0. So this we give this equation number 4, and this is one number equation, this is 2 and 3. Then we get equation number 4 subtract with minus equation number 1, 2 and 3. Then we write it, and we get these types of equation. Now we need to solve this equation in modified simplex method or two phase method. So we write it the constant value. So minus 3x1, this is minus 3, and minus 3x2 minus 2 lambda 1 lambda 2 lambda 3 1 0 0 minus 1 and right hand side minus 8. Okay, so and this is this equation we write it in this equation, 4 minus 2 1 minus 1 0 1 0 0 6 and so on. Then this equation, so this equation a1 plus 4x, okay, this, and write it in this format. Okay, so next, minus 2 4 lambda 1 1 0 minus 1 0 1 0 0. Then we write it 1 1 0 0 0 0 0 1 and 2 right hand side. This equation, this three equation we write it, and this equation we write it this. Okay, then we solve this. Then we see that which uh, column has which column has maximum negative w. Then we both are same, so we select first column, and then we get the minimum ratio or common ratio. Then this is the method of simplex, so 6 by 4 equal to 3 by 2, and this is negative, so avoid 0 also, this is 2, so this is a minimum, so we get this is the key column, and this is the key row, and this is the key element, so this is a key element 4. Okay, then we go to the next iteration. Minus w a1 is, so a1, now this is a key element, so this element is divided with all of these members, because we need to produce it 1, and all the element in this column other than this is need to be 0, and so a1 is exist variable and x1 is entering variable, so we write it x1 a2 s1 and minus, so we write it first this write it this row with by dividing by 4, so we get 1 minus 1 by 2 1 by 4 minus 1 by 4 0 1 by 4 0 0 sorry 1 by 4, and this is 3 by 2, so we need to produce other than this member is 0, So we write it this in for this row is 0. So how to produce it 0? If we this is a actual row, but we need to produce it 0. So this is a old row, so we can write it this is R3, so we write it R3 minus plus 2 into R1 R2 dashed is equal to R3 dashed. We write it. So if we write it, we can get minus 2 this plus 2 into R2 2 into R2 dashed. R2 dashed means new R2. So this is. So we can write it 1 for this. So this is 0. So this. So every member in this row element, every element in this row we can multiply with 2 and adding this row, and we can get this R3, okay, from this equation. Now we write it. So minus 1 minus so 4 plus 2 into minus 1 by 2 is equal to 4 plus 4 minus 1 is equal to 3. Okay, so you can write it 3, and it's so on. So you can write it. So if you check it by calculate it, so this is same as procedure. So 0 plus 0 plus minus 1 by 4 is equal to minus 1 by 4 minus 1 plus 0 minus 1 0 plus 1 by 2 1 by 2 0 0. So this is 0 and this is 1 by 2. Okay, so 1 1 and it's 0. Okay, so we can, and this is 2 into 3 by 2 is equal to 3. 0 plus 3 is 3. So we can form this R3 dashed, and now we can form R4 dashed. So we can write it. Actually this is 0. So this, how can we get this? This is 1 and this is 1. So 1 minus 1. So we can write it R4 dashed is equal to R4 minus R4 R2 dashed. Okay, then 1 minus 1 is equal to 0, and so on for every member. So we can multiply it 1 and subtract with fourth number of 4 row R4 R4 and we can get R4 dashed. Okay, so I write it 3 this is minus this is minus 1 by 2 1 minus 1 by 2, okay, this is 3 by 2 and so on, minus 1 by 4 1 by 4 0 minus 1 by 4 0 1 and 1 by 2, okay. So this also will be 0, so we can write it 0. So how can we get this 0? If we multiply this r2 dashed with 3 every element, this element, and adding with number this row, so we can get it will be 0. And if it is 0, then we calculate the same manner in every member or element in this row, okay. So we can write it r1 dashed is equal to r1 plus r2 dashed into 3. So r1 is minus 3 plus 3 into r2 dashed is 1 equal to 0, okay, and so on. So we can write it 0 and so on. So we can write minus 9 by 2 minus 5 by 4 1 by 4 1 3 by 4 and 0 minus 1, and this is minus 7 by 2, okay. So we can get it. Now next iteration is needed because here is W is section is minus. If every element is 0 or positive number in W element, then we stop iteration. So this is a most negative number, so this is the key column, and then we write, and then we then we find the common ratio to divide the every element of RHS with the key column element. So this is minus, so we can avoid it, or this is 1, okay, or this is 1 by 3. So we can, this is a minimum, 1 by 3 is minimum, so we take it, okay. So next iteration minus W, and also we can check it that this is minimum ratio, so this element is the key element. So every element of this row is divided by 3 by 2, and we can get 1, this key element. So S1 is the existing variable and x2 is the entering variable, okay. So we can write it x1, a2 and x2. So we can write it 0 1 minus 1 by 6 divided by 3 by 2, plus 1 by 6 0 minus 1 by 6 0 2 by 3. This is the RHS side. Also we can write it 1 by 3. Okay, if we get this, so we can remove these types of, because we need or write it also this section. Okay, so now we can get this row. Okay, and also every member of this column is 0, so we can write it 0. So how can we get this? This is a existing row. What is the existing row? R2 minus, if we minus this with R3 dashed into 3, we can get 0. So this is the new R2 dashed. So R2 is 1 minus, so sorry, R2 is 3 minus 3 into R3 dashed is 1 equal to 0. Okay, sorry for interruption. So this is 0 and so on. So we can write it into 3. So this is also 0. This is 2. This is minus 1. This is minus 1. This is 5 by 2. And this is 1. This is minus 2. Okay. So we can form this row. Now we can make this element 0. So how can we get this? This is R1 dashed, and R1 dashed is equal to existing in जो है हमारे पास पहले वो भी है R